Good afternoon and welcome to our next session on the Festival Hall stage. And as you can see, there is an empty chair alongside me. That should have been occupied by the architect Ian Ritchie, but very sadly he is ill and has not been able to travel from London. And he has asked me to read his paper on his behalf. And he wanted to introduce himself by saying that the text that I will read are obviously his words. So when I say I, when I'm reading, it's referring to Ian. And he considers architecture to be his wife, and art, writing, poetry and engineering as his mistresses. Ian considers himself fortunate to know many neuroscientists and molecular biochemist friends, as well as several Nobel laureates, who are more than just the acquaintances that he made through researching and designing the Sainsbury Welcome Centre, about which we'll talk. And that he really wants to promote knowledge and to advance knowledge in relation to architecture through these other disciplines. He has an insatiable appetite to understand more and to see what is relevant to design. He also asked me to introduce myself properly in his work. Now, I'm not quite sure what that is, because I'm the curator for the World Architecture Festival and have been since it started. But I think Ian in particular wanted me to refer to two things in which he was involved with me. One was running the Royal Academy Forum at the Royal Academy of Arts in London, which I did from 2000 to 2014, which was an interdisciplinary design discussion group where we had architects, artists, and all those creative people who are members of the Royal Academy, as well as reaching out to other people, including neuroscientists, the physicists, Roger Penrose, composers, choreographers, theatre directors. And so it was truly multidisciplinary. And so that was one thing that I was a convener of it, and Ian, as a member of the Royal Academy, was a common, frequent contributor, as well as always available for advice. And the other thing that Ian and I collaborated on was a series I curated for University College London called Think Space. And the inaugural event in that was indeed about the Sainsbury Welcome Centre, including its then director, John O'Keefe, a Nobel Prize-winning neuroscientist, the artist Dryden Goodwin, and Ian himself. And the subject we talked about there was the eye, the brain, and the building. And then that series continued for several years with similarly interdisciplinary content. So that's by way of background. I will read Ian's paper, so please bear with me if I don't sound completely natural. I've tried to read it through to get the right sort of emphasis and stress. And I'm afraid we won't be in a position to take questions because I won't be able to answer them, I suspect. But anyway, let's have Ian's paper. It's called Memory, Reason and Imagination. And it's about the brain. And he says that the human brain, can we have the first, oh, there we got it, good. The human brain is about 2% of the body weight and weighs about 1.5 kilograms. It is very soft and deep red in colour. It is made up of 80 to 95 million nerve cells, with each cell connected to around 10,000 other cells, which means there are about 1,000 trillion connections, which is a quadrillion. And a trillion is 1 million million, and a quadrillion is 10 to the power of 15, 1,000 million, just to give a sense of how many this is. And as a visual comparison with those numbers, there are some estimates that put the number of stars in the Milky Way at between 100 and 400 billion, which is also the lower limit of the number of galaxies in the observable universe. In other words, the quadrillion connections in the human brain is an almost inconceivable number. Sir Martin Rees, the astronomer royal, wrote that the human brain is more complex than the universe. So he was acknowledging that the human brain is more complex in his own field of study. Understanding the neurobiology of the brain, however mind-bogglingly complex, and understanding the brain informs our responses to the environment. It is essential if we are to design better and improve the built environment and create healthier human societies. I will express my thoughts on memory, reason and imagination, illustrated in part through explaining the Sainsbury Wellcome Centre on Neurocircuits and Behaviour at UCL, University College London, as an architecture expressing these three aspects. Memory, reason and imagination are all distinct cognitive functions. Memory stores past events and is a factual and active resource. Reason provides a rationale for design, philosophy and imagination, and it can deliver a visual metaphor beyond the architect's brief as a poetic synthesis of memory and reason, such as climate change. Reason is a process of using logic and memory to form conclusions about past events or to predict future outcomes. Imagination uses stored memories to construct new ideas or scenarios. Why did I pick these three words and not, for example, perception, thinking and expression? The reason is memory. I recall Jean-Laurent d'Alembert, a French mathematician, mechanician, physicist, philosopher and music theorist. He also became a lawyer, but until 1759 he was, together with Denis Diderot, a co-editor of the first Universelle Encyclopedia. His notion of memory is based on history of religious and sacred knowledge and natural phenomena and man's use of them. We should be seeing, we've jumped forward a bit, I think. Anyway, we hope the images will catch up with us. Most people think of memory as a repository to recall the past, whether personal or as cities containing memories through old buildings. And if imagination is lacking, then this is their haven for wanting the status quo and repetition. So on to memory. The sensory data that we receive is about 80% visual, about 10% acoustic, and the remaining 10% is smell, 5%, touch, 4%, taste, 1%. And those figures come from Heilig, published in 1992. And these senses, then, are the source of all knowledge and memory. Now, does the same hierarchy and weighting apply to our appreciation of architecture, one might wonder? And is attentional capture the most relevant metric anyway? Of the 80% visual input that we have in our brain, the brain only uses 10% of it. 90% of what we think we see comes from the brain itself. Now, perception is not just through the eyes in that case. Our brain did not evolve to experience the world, but to communicate to each other and to make things, as in Homer Faber, man the maker. The special feature of the Colombo Museum in Cologne, sorry, I need to catch up with this. Yeah. The special feature of the Colombo Museum in Cologne by Peter Zumthor is notable for there were no labels or explanatory texts in the exhibition, no chronologies and no visible connections due to the object's style or age. It depends on you using your own memory, feelings and thinking to understand the exhibit in your own terms. This is harmony with the calm poetic aura that emanates from the museum spaces. A memory needs encoding and then storing, and then it follows the neural pathways when it's being retrieved. To keep memories alive, you need to use them, which means keeping the neural pathways strong. Today, we know where in the brain memory is stored. There are three areas of the brain involved in explicit memory: the hippocampus, the neocortex, and the amygdala. The hippocampus is where episodic memories are formed and indexed for later access. It is located in the brain's temporal lobe and is also responsible for storing and retrieving memories. Episodic memories are autobiographical memories, such as specific events in our lives, like the dinner we had with friends last Friday. Now, how do we know this about the hippocampus? In 1953, a patient named Henry Mollison with epilepsy had his hippocampus removed. He made no new permanent memories. Fresh memories lasted only a few minutes because he obviously lacked the hippocampus. The hippocampus is crucial to consolidating long-term storage in the neurocortex, within which short-term memory is primarily stored in the prefrontal cortex, which is a specific region, about 30%, within the neocortex. Now, once memories are consolidated, they are stored in different brain regions depending on the type of memory, such as the neocortex for face and events, declarative memory or conscious reflection, the cerebellum and the amygdala for procedural memory, which is implicit or without conscious thought, and then emotional associations are in the basal ganglia for motor skills. Now, turning to the neocortex, over time, information that's stored temporarily in the neocampus can be transferred to the neocortex as general knowledge, things like knowing that coffee provides a pick-me-up. Researchers think this transfer from the hippocampus to the neocortex happens while we sleep. And then the amygdala. The amygdala is an almond-shaped structure in the brain's temporal lobe, and it attaches emotional significance to memories. The amygdala is responsible for processing emotions. The hippocampus and the amygdala are both parts of the limbic system. They are especially relevant to creativity and imagination. In conjunction, the amygdala and the hippocampus are the two parts of the brain that help to form ideas. Limbic system is on the edge of the cortex and is concerned with instinct and with mood. Instinct, perhaps for the architect this is intuition, and it's unconscious reasoning from fast processing of knowledge stored in memory, and it compares past experiences with future situations. The comparison is probably through the patterns that the brain has learned. So how much knowledge have you have stored from your experience is crucial to developing new ideas. Architects have historically designed largely by intuition unless they're experimenting with new techniques, and that makes them dependent on the skills of the guilds, or nowadays the architect depends on the skills of the industry and of being able to collaborate with it. So, are memory and imagination two sides of the same coin? Yes, they are to a degree. Imagination depends critically on memory in that it is hard to imagine things that aren't at least made up of elements that you know. Memory provides the building blocks for things to be imagined. Memories of things that have happened before also provide the building blocks of imagining possible features. For example, was this a good idea or not? Or this worked well last time, and so forth. So memory is certainly critical for imagination. And what are the vital functions of forgetting? The brain is in permanent conflict between making new and reinforcing memories, and as well as weakening and destroying them. Memories are the foundation blocks for imagination. I do not believe that memories are anchored in space, as proposed by Bachelard. His reference to such containers as the spaces in the home are mechanisms for recording memories. But I use letters of the alphabet to part my memories. And now looking at reason. How did I or we approach the design of the Sainsbury Wellcome Centre for Neurocircuits and Behaviour at University College London? From earliest times, philosophers have tried to define when matter becomes mind. In relatively recent times, say the last 500 years, it was Descartes who laid the foundations for rationalism with the philosophical view that regards reason as the chief source and test of knowledge. The most important contributions to philosophy include formulating the first modern version of mind-body dualism and shifting the focus in philosophy from what is true to of what can I be certain. Now, philosophers were joined in their attempts to do this by psychologists, then by neuroscientists, and most recently by theoretical neuroscientists, whose focus is on the experimental biology of the brain. Perhaps now, in tandem with theoretical investigation, there will be more profound insights into perception, cognition, and behaviour. This is the basis for the creation of the Sainsbury Wellcome Centre for Neuro Networks and Behaviour. We have used some of those insights in its design. Its design was selected through an international competition. We knew nothing about the needs of systems experimentalists and theoretical computational neuroscientists, but of the final 3 practices, 2 produced plans and models of the new building and designs for the laboratories. But we had no memory or reference point, so we didn't attempt to draw a new building or laboratory. Instead, we asked ourselves 2 reasoned questions. First, how could we envisage a neuroscience research centre? And 2, how could it evolve and be relevant over the next 60 to 120 years? And to these questions, we had no answers, at least initially. So we put forward in our competition submission a notional 12-month research programme. We undertook our own research programme, interviewing and learning from leading neuroscientists across the world, with a background in theory, computation, experiment, in cellular, cognitive and clinical developmental neuroscience, in physiology, in systems and neuroengineering, and the techniques that are used now and are likely to emerge in the future, such as electrophysiology, neuroimaging, molecular methods, functional resource imaging, and magnetoencephalopathy, etc. Architecture is imagined, and when built, it shapes us. This was recognised by the Academy of Neuroscience for Architecture, which was established under the auspices of the 2003 American Institute of Architects Convention, which was held in San Diego, which is the home of the Salk Institute for Biological Studies. The Salk Institute, designed by Louis Kahn, was completed in 1965. The teak used in the building underwent a huge restoration after 50 years, as Kahn wanted there to be no stains or sealer used in the building. And also he wanted pozzolanic concrete which was, as it was struck, with no filter or paint. And then there were light wells below and service floors above the labs, which define the section of the building. Now, pozzolan is added to a material like lime mortar or Portland cement. It's volcanic ash and crushed brick, although modern types can include manufactured porcelains like pulverized fly ash. Now, when the Salk Institute was built, the newly coined discipline united the fields of anatomy, physiology, pharmacology, psychology, medicine and behavior with biology, immunology, genetics, molecular biology, chemistry, physics, electromagnetics, and artificial intelligence. The need to recognize indeterminacy through spatial adaptability and infrastructure flexibility was absolutely fundamental. And then, so we were looking at that, beginning to ask what a completely adapted architecture would look like inside and outside. Would it be much different from a conventional laboratory space? Initially, we had no preconceptions. So we didn't dare draw a single line of the building because we didn't know what it would look like. The role of the architect is to design for the body in space as well as for the mind and spirit. As architects, we understand space as a physical entity, but so do neuroscientists, but their research, and particularly that of John O'Keefe, who became the acting director of the Sainsbury Wellcome Centre and later won a Nobel laureate for his work done in that laboratory. His research was very much about how we process where we are in space, and it led to interesting understandings of space in neuroscientific terms, and that helped us, as did various conversations with Peter Dayan, who was a winner of the Brain Prize and now director of the Max Planck Institute for Biological Cybernetics in Tübingen in Germany. John O'Keefe's work on place cells within the brain showed or helped us to understand how we navigate our environment. And when he was doing his research, he was a very young scientist, and he spent a hell of a long time, apparently, according to colleagues, just looking at how rats moved. And no one quite knew what he was up to, and he wasn't very communicative about what he was doing. And then he wrote an absolutely seminal paper, which was based on that research, showing that rat brains, i.e. mammal brains, had these things called place cells, which helped them understand space and how to navigate through it. And that was basically what made his reputation. So our ability to navigate through space to where we are and what moments to make next to are governed by cognitive maps based on 4 cell types acting together. So if you consider the threshold to a house, or in front of a large reception desk, or at the edge of a building, all of these are sensed and processed by our brain. And we make choices about what to do next when we see them or cross them, which are very often based on the basis of risk and reward. Architects design spaces and places. So what better partner for this project? We had to learn his language and he ours. We needed to learn how to design with the mind in mind. Neuroscience is beginning to offer insights to enable us to quantify the design process, which has so far consisted of a creative mixture of instinct, art, and engineering. Man's physical and psychological evolution, like that of any other living organism, has been shaped by environment and by biochemistry. However, we, as in humankind, are the first animal on the planet capable of imagining and realizing how environments are in new environments that in turn shape us and evolve as we evolve. Architecture can thus be defined as a neurodesign learning loop. Understanding the laws of physics and engineering has not inhibited our creativity, but given our creativity wings. However, we do really know what enables an architect during the design process to produce beautiful building, one which makes a human spirit soar or makes a human being feel comfortable and nurtured? Or are we still designing intuitively? And we then turn to the notion of poiesis, which is a creative process which is used to realize a project which embodies emotions and the values of those involved. When I do this, I first write a poem. Dreaming of a project, what do magicians do? The science of magic? As neuroscientists research the mind, magicians play with it. How? Do they misdirect us, divert our attention, blind us temporarily? Do they fill in the gaps, fill in the margins between the frames of a film? To be able to read our reality requires a reference, which is our dreams. Some of our dreams question reality's reality. Here I am designing with the mind in mind. Dreams, I try to build mine, avoiding the nightmares. And from that poem, an aphorism may follow. Architecture has two distinct phases, the mental dream and reality's nightmare. From that, we can make an etching and the initial moves from the etching towards a visual metaphor. Here is the etching, dreaming of a project made in 2009, and then on the right, what is a neuroscience lab, an ink drawing made in 2011. And then from the Ian's inklings, we move on to another diagram which begins to look more like a design as opposed to an artwork. And this is about the connectivity within the SWC. Blue is laboratory, red is the satellite, purple is support space, and yellow is write-up space. And another of Ian's inkings here, which is the cross-section, again showing connectivity, blue being the lab, red the satellite, a purple support, and yellow write-up. So using the same color coding, which is beginning to become recognizable as a design of a building. The essence of the Sainsbury Welcome Centre at UCL's project is based on providing spatial experiences that will help attract some of the world's most inquisitive and creative minds to divine questions that would enable collaborative theoretical computation and experimental researchers to help unlock our understanding of the human mind. And this came about because John O'Keefe, who was a professor at UCL, won a Nobel Prize, and the provost, the head of the college, called him in and said, well, what would keep you staying here? Because he was being approached by every well-funded university in America to come and set up a research institute. And he said to the provost, you know, I like London, I like being here. Why don't you give me a research institute? And the provost said, well, leave it with me. And he contacted The Wellcome Foundation, which is one of the big medical research funding charitable funds in the UK, who were prepared to offer a substantial grant, and also the couple, David and Susie Sainsbury, who are one of the biggest philanthropists in the UK at the moment. And between the Wellcome Foundation and David and Susie's foundation, they found the money to create the centre, which is why it's called the Sainsbury Wellcome Centre, and to keep John O'Keefe in London rather than travelling across the Atlantic. Now, architects should be keen to understand how best to provide spaces that work best for the occupants. The challenge is that our needs change throughout the day, across time, according to our state of health or the tasks we were being asked to engage in. Nothing stays the same, and predicting change is fun. Now, how can architects design for flexibility and adaptability? For us, they are very different aspects. Adaptability is physical organisation and dimensions of space that change. Flexibility is softer. Flexible light, flexible quiet, flexible temperature, smell and colour. And as designers, we begin to react to these dynamic needs. Then we can move in the right direction. Crucially, the diversity and potential of the lab was rethought. We had double height volumes, biotheatres within the lab, molecular servicing, and simple to change configurations to the enclosures of the space. The resulting spaces provide high visibility and connectivity with multiple advantage points, lots of permeability, and intimate volumes reflecting human preferences. The multi-scale approach reflects a scale-free network of the brain. And here we have some pictures of the building. Architecture is a uniquely multifaceted discipline, integrating perception, imagination, and artistic expression with the physical world of space, light, and form, construction and its materiality. And in this, we create the buildings in which humans live and ideally thrive. Until recently, little has been known about how our brains, bodies, and buildings interact. Although architects for centuries have depended on intuition and experience to create environments that influence the people who use a space, we know we have much to learn about human responses to environmental stimuli. Neuroscience is beginning to provide us with an understanding of how the brain controls our bodily activities, affecting how we think, move, perceive, learn, and remember. There is now concrete evidence that one of the properties of the human brain is neuroplasticity. That our brains change as we learn, and that our brain is changing partly in response to our environment, is part of what we are learning. Now, this affects or helps to lead to a concept of an architecture. This is Ian's image of the idea of a concept. And then we move on. Arctic sea ripple is the image on the left here. Climate change, Ian says, is a concept, and its translation with knowledge about space and light and daylight. I'd like to suggest that the history of architecture is also the history of the way light has entered buildings, beginning with small openings in masonry walls and roofs, and then to infilling those lights with small pieces of paper, translucent skin or glass, right up to total glass enclosures. For the last 1,000 years or so, glass has been used almost exclusively worldwide to complete the building's protective enclosure against wind, rain, and noise, while allowing visual contact to be maintained with the outside world. How to use daylight intelligently for the scientists, relaxing, conversing, writing, computing, experimenting, knowing a little more about light was an important part of what the design is trying to do. For example, we drew on Russell Foster's circadian neuroscience research, which identifies how our biorhythm is triggered by a specific wavelength of light. Neuroscientists have begun to discover that the levels and wavelengths of light to which we are exposed affect us in the most profound biological and physiological level. Research shows that in humans, light influences not only sleeplessness and alertness, but hormone secretion, heart rate, body temperature, and gene expression. Consequently, there should be a shift toward appreciating more than just the aesthetic appearance and visual properties of architecture. Our emotional response, awe, calm, intimacy are all important to how we live and work. To visit a cathedral without the sounds or the smell of incense is to experience the architecture without people, without the culture. Now, does our architecture allow appropriate natural cycles of light into buildings, particularly for people who spend a lot of time inside? The entire wall of Sainsbury Welcome Centre is of translucent glass, which not only allows soft daylight to filter into the building, but enables a soft change of day to night to register on the walls. Now, why is there a wavy facade, and why the colour blue, or more precisely, blue with a wavelength of 580 nanometers? This is what Russell Foster identified as a wavelength that makes us most alert. The advantages of translucency, which is a soft distributed light, sufficient lux on the whiteboard, and the integrated opening windows for views and fresh air, and the changing light, plus the external cast glass louvers on the outside, protect from sunlight and give privacy. And the interior of the facade here is a continuous whiteboard. Sightlines, long and short, horizontal and vertical views, and access to outdoor spaces seem to be correlated with mental and physical health in terms of heart rate and stress levels, as well as in healing. This is the roofscape of the centre. In the SWC roof garden, the seminar, cafeteria and administration, all at the same level, are designed to encourage feelings of contact and interaction with the natural world, with greenery and with weather. And here we have spaces for computational interaction. Now, each of these, the sort of interaction and the sort of spaces is a matter of choice. Isolation or togetherness help us to control a personal environment. There are many spaces for chance encounters throughout the building, which are soft or hard areas, and they can cater for accidental or intended encounters, which is part of how really thriving academic community works, of course. Now, the whiteness of the building's main mass refers to an iceberg, and it is melting at the corners. As the wavy facade turns a corner, the glass becomes more immaterial, like water flowing, and this is a metaphor for climate change. So this is the corner flow, this is the ice melt, and then this is the south facade, which has wind mitigation and interactive solar shading. Now, these are both artistic and metaphorical elements to the exterior. On the south side, the building appears as a fractured surface and moves to the wind, as in the sea's currents move to ice floes. And then in the public domain, in the sort of main street facade on the north, there is a reference to Bach's great compositional innovation, the Prussian fugue. Space to an architect is not the same as space to a physicist or to a neuroscientist, and even the spatial notion for professionals in architecture, urbanism, theatre, choreography and gaming design are all quite different. For example, in film, the building is treated as an urban brain. But when being normal humans, we all experience architectural space with our memories, our reasoning, and our imagination. Each of us is a complex organism of habits with an active mind and emotional responses. And then this is a quote from the now the leader of the group at the Sainsbury Welcome Centre. The SWC is a wonderful place to do neuroscience, and a major part of that is the building itself. Energy and ideas flow naturally through the spaces, as if the walls themselves were designed to think with us. The seamless interplay between experiment, analysis, and theory is at the centre of the building's ethos, both scientifically and architecturally. There is no better place to think about thinking. And there is Ian on the screen. The centre was officially opened on the 23rd of May 2016 by the Nobel laureate Professor Eric Kandel. His inaugural lecture was called "We Are What We Remember, the Biological Basis of Individuality and the Nature of Age-Related Memory Loss." Now, we can all experience the building as an independent observer, or with others in a social context, or indulging in one's imagination, or in any combination. Great architecture should connect reason and technology to emotion, as well as connecting space to the soul. I am motivated by ideas, by creating them, developing them, and bringing them to realization, because they have values which are social, physical, intellectual, and moral. And this is the cover of an edition of AD that Ian edited in 2020. The construction of a better architecture requires a better understanding of how our body and mind feel in space. And equally, a better world can only be achieved through respecting memory of and appreciation for the best things in our urbanity. Well, thank you, and my apologies for my not terribly fluent reading of Ian's wonderful paper.